So, hey guys, in the last video, what we actually did is we went through and kind of broke down what these equations were referring to, this concept of velocity, acceleration, displacement, and time. And we're going kind of quick in these videos. Some of my old videos, we really spent a lot of time breaking everything down. But anyway, let's go through in this one and let's take these equations that we've learned and essentially any 1D there, any 1D motion problem, you should be able to solve simply by using what you see on this page. So I'm going to take this, I'm just going to copy it and bring it over and let's do this first example problem. Let's paste it right up on underneath here. Notice I've even got this little template for me to kind of use as well in here. And so here in our first example, a race car is starting from rest. And so the race car starting from rest, and there's that keyword rest, that simply just tells me that my initial velocity is 0 meters per second. So that's kind of handy. And now it even tells me it accelerates at 5 meters per second square. And if I was unsure about what the 5 was, that unit of meter per second square, that kind of clues me in as well. So 5 meters per second square. What is the velocity of the car after it has traveled 100 feet? So it's asked me to solve for the final velocity, and it's given me this distance or displacement of 100 feet. So that is my x. So it's telling me we've traveled 100 feet in this problem. Now, this is a very easy problem, but it's done one thing to kind of throw at us at this point, and it's given us this wrong unit. So let's take a moment, and hopefully you remember how to do this, but I'm just going to do some engineering bars here, or my version of engineering bars, and I know that there's 3.281 feet in every 1 meter. So I'll just take my trusty FX calculator here. That will end up 100 divided by 3.281. And so 30.5 meters. So there I've got my displacement changed over. So now the goal for you is to try and find an equation to use. Well, we would have a problem using the first one because we can't find an average velocity because we need two velocities to find an average. So that's not going to help. And we don't have a time. We have a displacement, but we don't have time. So let's rule that out. And a matter of fact, the fact that I keep saying we don't have time should help you with something. Notice, has time. If you remember, there's a nickname for this third one. This third kinematic equation I've written is also known as the timeless equation. So I'm going to just write it down. V square, velocity final square, is equal to velocity initial square plus 2. And instead of the delta, I'm just going to write x down. Because if we were writing it like maybe your teacher might want, x initial would be equal to 0. And my x final is actually this 30.5. So in the end, x, and if you paid attention to the last video, about the only time we really need this x initial, x final way of solving the problem and actually using the delta x is usually if there is a chase in the problem. So you have two objects, one chasing after the other, something of that nature. Maybe they're going to collide or something like that. So here's what I'm going to do. I'm just going to go ahead. This equation's already set up to solve for v. Let's just substitute in and get our answer. So velocity square is equal to 0 square plus 2 times 5 times 30.5. And you got to kind of love this because that's 10. 10 times 30.5 is 305. So we know that velocity square is equal to, and somewhere out there, there'll be somebody tell me, you didn't write your units out. Yeah, I know, I'm just a terrible human being. We'll go back, though, and look at the units in a second to make sure they come out with what they should. So let's do this then. So there's only one step left mathematically, and that's just this. Let's take a square root of both sides because we're looking for velocity, not velocity square. So let's grab our calculator again. Square root of 305, not 0.05. And that is 17.5. So our final velocity is 17.5. And somewhere out there you may have a teacher that's like, well, prove it's meters per second. Well, okay, we can do a little dimensional analysis. Let's go back up here to this stage in our formula. So we had 2 times 5, and so that was, the 2 had no unit, so we had a meter per second square times x, and x was just meters. So that actually ended up a meter square second square. So if you look, we then took a square root of that, which, hey, lo and behold, the square root of a meter square second square is a meter per second. So everything is good with this example at this point. All right, so there's our first example. So a basic car accelerating. We'll do a second video, or we'll try and take a look and do another one of these. And we'll go through. I'm just going to work one problem to video so that they're not too overwhelming. Anyway, thanks for watching, guys.